-6 meters. That's what he's doing, right? So this is the opposite, okay? It means the same thing. So this means the same thing. So what this means is I'm using my whatever unit I'm going to. So micro, this is mu, it's micro, or nano or whatever, centi, deci, milli. I'm using that, the smaller unit, I'm using that as a 1, and then converting that to the fraction of the larger unit it represents. So what I usually do is bigger unit gets the 1, right? So I do 1 meter is the same as a million, or micrometers. That's what I do, right? So I'm basically taking a bucket, it's the bucket analogy. So my bigger unit is a bucket, and then how many of my littler units do I have to put into the bucket to fill up the bucket, right? What they're doing is I have how many pieces of a meter, right, do I have to chop it into to get my smaller unit? Okay. So this is just a fraction of a meter, right? This would be 0.02. Yes.
So if it was -6 for there, 5 here, or 6 there. Always possible.
Because if I'm doing 1 10 to the -6, right? I have to go this way to make it smaller. So my decimal is here. 2, 3, 4, 5, 6. You're right. The other side. I'm trying to do that in my head. It'll always work. Yeah. So it's just a fraction of a meter, really. So they're making that larger unit for negative. That's what that means. That's in the packet too. A lot of the lecturers use that, a lot of professors do. For the bigger one, if they make us think about it, we should like use this. It's not incorrect by any. So let's do. You do anything. So let's say I do micrometers to nanometers. So this is multi-step, right? Doesn't just go to the base. So I have to start with, let's say I have 7.89 micrometers, right? So we start with what we know. We want to get rid of it, right? So that has to go bottom. This is technically over 1, right? So micrometers, and I need to go to my base first because I can't directly convert to nanometers, right? So meters goes up here. Instead of my larger unit getting the 1, I'm going to give this guy the 1, where it's -6.
So if it was reversed, you would put 10 to the +6?
No. Because this is still true no matter how I flip it, right? It doesn't matter what's on top and what's on bottom. What matters, why it matters is what's on top.
Would you switch meter and meter?
Yes, that's what you mean by making the meter the 1.
Yeah.
Yes, that would be positive.
So that's, I think, what was like.
Positive. Because this is, I have a crap ton of micrometers putting into 1 meter. I have a fraction of a meter. That's my second. So that's the answer. I thought you know which one on top. Okay, and then I need to get over my meter. And I need to go to nanometer, make it straight. So we're gonna do that again. With this guy is my 1. And this guy, nanometer is even smaller, so it's a billion. So it's -1.
You know, the only meters, what are they on the exam?
You only need to know deci, centi, milli, and those are smaller than 1. And then kilo will just. But if it helps to remember these, like if you just want to, because it's not a bad thing not to be able to not have to look at your conversion packet, is that or any of your little is 6, no, because 12. No, that's more. Let's use 12. Yeah.
Is that so you can have
That is mu. It just means micro. For each. So we're solving for nanometers, right? The conversion. So if I crossed out everything, the only thing that's not crossed out is what I want to get to. My answer is going to be. Okay. When you put those signs and notations into your calculator, they're in parentheses, but they're not going to work. Your calculator's going to break them up. They're going to multiply everything by 10, but if we're not multiplying by 10, we'll work. Any questions on that? For those parentheses, because that's really.
Something right here, it's like 7.25. And then like the bigger number was on the bottom. You know, like it was like you had they were separated almost. Would you do on the multiplication on the top first and then divide?
It's always multiplication first, then division, always. So you can also look at it like this. Divided by one. One time. So you multiply these guys first, multiply these guys first, whatever your total is here. So if we were going to, like, let's say the meters to micrometers. We still put meters on the bottom, right? Because we want to get rid of meters. We're going to micrometers, which is a one step. Okay. You would still write this one as one. For your instructors. Ask.
The meters are larger than
The meters are larger, so they're gonna get our fraction. I don't like doing that, I'm gonna be honest, because one,
So whenever there's a, I think like a small number, there's a large number, or a large number, there's a small number.
so we're always gonna match this, we're gonna match our units across the map. It doesn't matter where this goes, where the one goes. The one is always going to go to the smaller unit. That is what your professors are saying, to use the -6, -9, whatever, okay? To use the fraction method for the larger unit, that one is just always going to go to your larger unit. It doesn't matter where that larger unit is. So it could be on top or on bottom, it doesn't matter. Smaller unit gets the one in this case. Yeah. My method is to give the larger unit the one, and then to have a fraction of the smaller unit to have a positive. X. Like this. This is. Of what I know, Lion and Dr. Kate knows, and he was actually Dr. I find that a little bit more confusing, which is why I opted for this one. But if your professor wants you to do it a certain way, you always take their advice over mine. None of you look happy looking at me. So,
that is like.
yep. So let's say we're going to from a meter to, or let's say we're going to a micrometer to a nanometer. Same number. Or micrometers. Micrometers goes the bottom, so we can cancel out. Okay, I have to go to my base unit. My bigger unit gets the one, and I fill up that with how many it takes to fill up that bigger unit. So that's positive exponent. And then my meter's up here, and then I can go to nanometers. Meters is bigger, so it gets the one. 1 times 10 to the 9 is how many nanometers I need to make up one here. No, because they're not on the same side. So if this were negative, right, that would work. That would be on bottom, we'd be multiplying it. So if I multiply by a decimal, I get a smaller number. If I multiply by a fraction, right? If I multiply by 0.5, I'm really taking half of that number, right? So I'm making a smaller number. If I divide by a fraction, I get a larger number. Okay, so this wouldn't be on bottom. It would be on top. Okay. This just changes if we're multiplying or dividing by a fraction or a decimal. That's all that's changing. Ask your professors which one they want you to use. I find this one easier to understand, because I always have bigger units than the one. Okay, it is opposite over here. Your smaller units always gonna get the one. I don't think they cares. Can't remember that. So the text okay with it? Cool. She used to be a little bit more rich on that. So if you have Lions, I would stick with this one, but he's also really nice. So talk to him. Please talk to your professors about what can you do, what they want you to do. So I prefer this direction, because I think it's a little easier to understand the bucket pattern versus the fraction.
Because if we were doing like milli, it would be 1 meter equals 10 to the 3 millimeters away.
You would, if you're doing Dr. Lyons' method with the negative exponents, or if you're doing my method. Lyons' method is you're going to use negative exponents. He wants you to use those negative exponents for your smaller units because he wants you to remember they're smaller than one.
If you were writing it out though, the Dr. Wright would be like.
So let's say I have
1 meter.
1 meter and I want 2 millimeters,
Yes.
right? So 1 meter times meter. Right? So in Lyons' method, the smaller unit, which is our millimeters, is going to get that negative exponent. Or sorry, positive exponent is going to get the 1. And you're going to have a negative exponent on your larger unit. So 1 times 10 is negative 3,000.
Write it out first. Before you start to practice, like, you know, something.
Yes, so what he means by that is, I don't even care about the numbers when I'm writing out my conversion. So, let's say this was like, something we don't know that version. So 2.4, let's say this is micrometers, right? Micrometers. What he's saying is lay out your units first. So you know, so we need to cross out micrometers. So micrometers has to go on bottom. The only conversion I have for micrometers is to my base unit. So I put meters on top. Okay, now that's crossed out. Okay, now I have to get rid of meters, and I, go ahead. Okay, so I need to cross out meters, right? And I need to end with millimeters. If I'm not crossed out, it means I end with it. Okay? So that's what it means if I write it out first, before any numbers come in. This is the same plan whether you use my method or use lines this time. Just depends on which one gets the one.
You know, so should I like write it off to the side, like before I start putting the fractions, should I put like 1 meter equals?
Yeah, you can do that.
Okay.
So my method would be 1 meter equals 1,000 millimeters. His method would be 1 times 10 to the negative third meters equals 1 millimeter. Because he wants to show
Write it as a
you,
fraction, it makes it like, I don't know.
yeah, you can write it as a decimal if you like.
I was right as like,
Oh, you can do 1,000.
no, that's. I'm just talking like 1 millimeter equal sign,
Oh, okay.
you know, before I start putting into the fraction, like, you know, because then I can just do either side and like. Plug it in. I think that's like a good idea.
Like this.
Oh, do I write instead of 1,000, do the 1 times 10 by negative 3? Is 1
Meter equals 1 millimeter. You have to write it like that.
Okay.
Because 1 times 10 to the negative third millimeters does not equal 1 meter.
Okay.
Right? Because my smaller unit is my millimeters. Okay? I cannot have a fraction of a smaller unit equal one of a larger unit. No, that works, right? He's making you use these negatives because he wants you to remember that these are smaller. Okay? If I use kilo are bigger, right? 1,000 bigger. This is 1 kilo. Like longer. Equals 1 times 10 to the third meter. Right? Positive exponent means kilo or bigger. That's what he wants you to do. That's why he makes you write that. My basis, my method goes over, you should know those conversions. I want you to remember those prefixes more than I want you to remember anything. I do it mostly on years. Deci is 10 years. Centi is 100. Milli is a millennia, so it's 1,000 years. Kilo, I remember very brassly, which is through drugs. So like drug cartels, they move kilos of drugs, right? Right? It's enough to get you in prison for a lot of years. Yeah, we could think of the nice way, which is bread. If you ever watch somebody in Italy make bread on TV through a cooking show or something, they're like, oh, I have 3 kilos of flour. Right? Just a big number, but you have to remember that's 1,000. I don't have a great memory one for 1,000. Oh, that's not on the. Okay, this is a density question. Anybody need this? So this is a conversion question, but I'm also doing it within a given equation. We do that a lot throughout chemistry because a lot of the time you're not going to do these straight conversions anymore when you pass this test. After this test, you're not going to do straight conversions anymore just for the sake of doing a conversion. Okay, you're going to do conversions so you can put something into an equation. Okay, so this one is a word problem. So a graduated cylinder contains 56.7 milliliters of liquid. Okay, when a 4,563 milligram sample is added, the volume changes to 4 7 or 72 milliliters. That's not enough. Okay. What is density in grams per milliliter? Okay. This is actually the density of a solid, not the density of the liquid. Okay, that's a lot of issue. This is not a, we're using the exact milliliter. Okay, we're not using that to plug into our density equation. We're using that to find out what has been displaced. Okay, how we find the density of a solid without using any sort of balance or using any sort of scale is by placing it in enough water that we know is in there. So if I have 25 milliliters of water, if I place a 5 gram rock in there and it displaces 3 milliliters, I know the density of that rock, right? Density of rock is 3 milliliters, right? The displacement value. Okay, with word problems, I want you guys to go through and see what's unimportant. Stuff that's gonna freak you out, but doesn't matter. Okay, I have a graduated cylinder. If this was a beaker, would it change anything? No. We would use a graduated cylinder, but it doesn't matter. Okay. It contains this much liquid. Okay. This liquid. Okay. This is the weight of my sample, so that has to be important, right? Because we're doing density, which is mass. Okay. Mass and volume. When it is added, okay, the volume changes to this much. Liquid. Change. Okay. What is the density in grams per milligram? Okay. I have milliliter here, and I have milligrams here, right? Is milligrams the same thing as grams? No. Okay. Are we going to convert that first, or are we going to convert it at the end? After we put it into our density equation. First. Much easier to do first. Okay. So let's just take that milligram 4, 5, 6, 3 milligrams, right? And we want to convert it to grams. What's my first step? Milligrams goes on bottom, let's go on top. Grams. Okay. How you know what goes on top is, can I do a one-step conversion? Okay, if I can do a one-step conversion, great, put what you need to end up there. If you cannot, go to your base unit. Okay. So grams, which one is bigger? I'm gonna do my method here. Which one's bigger? Grams. So that is our 1. How many milligrams go into 1 gram? A millennium is how many years? 1,000. Has anyone ever measured years by 3? No. Sometimes you measure year by 4. Nuclear. Yeah, you're doing 1 times to the third.
Yeah.
Okay. So what are we really doing here? What's our operation? Multiply by 1, divide by. But if you multiply by 1, does anything change? No. So I'm just gonna straight divide. So we're gonna divide that by 1,000, which should give us 4.563 grams. Someone check that for me. Do that next. But it should be, because it's. Yeah, that's right. Cool. All right, I'm gonna ask you a sig fig question because they never go away. Does my conversion factor mess with my sig figs? No, they're facts. They never change, so I do not care about the sig figs of them. Okay, they are exact, so I don't care. I have 4 sig figs here. I keep my sig figs, but even if I didn't, if I had a different number of sig figs here or whatever, I don't care. I'm gonna put as many as I get out of my calculator right here, because if I do any equation with any number, I want it to be as many digits as I can, because I want it to be as sure as I can. Okay, so that's our grams. Perfect. We're not gonna care about grams for a little bit while we do the other stuff. Okay, now I have a cylinder of liquid. It starts off 56.7 milliliters. Before I ask, is that the correct unit for density? Okay, so we don't have to convert that. Okay, I end up at 78.4 milliliters of liquid when I throw a rock in it. I'm gonna pretend it's a rock. Okay, what's my displacement? What does displacement mean? Yes, we're gonna subtract big number by smaller number because we're getting larger, so it's gonna be a positive number. So I'm not letting it water out. That is the density of my rock. Okay, I know. Alright, that's the volume of my rock. I know the density of water. Okay, this liquid is water. I don't care to find out the density of water and if the density of water is equal to 1. Okay, so if I have a mass and a volume and my units match, and I just put this into my equation for density. Yeah, what's the density equation? Okay, can I manipulate this if I wasn't trying to find density? Let's say I was trying to find volume. I can just flip somewhere. Yeah, it's an equation. Algebra. You can do it if you want. Okay? You don't have to memorize 18 different equations. Memorize the first one and just move it. Okay, so I can just plug, right?
So is the question asking for like the density of all of it after, or like
The density of the solid.
same?
What is density? That was the original question. Sorry, that wasn't the original problem. It is of the same one. Okay. This is usually water as a liquid, and I know the density of water, so I don't want you to tell me. Okay, so I have volume, so let's plug in. Density equals what goes on top? Grams. What goes on bottom? Just fine. What will our answer have sig fig wise? 3. Just give me all the numbers again.
7, 6, 4, 9, 8.
And I want 3 sig figs, right? So I start at the top, I start at the front. Does my 0 in the front matter? No, we did. 1, 2, 3. Look at this number behind to see if we have to round up. Does 2 make it need to round up? No. 0.210. 0 in people. And what is our units? Grams per milliliters. If I wanted to write this as a conversion factor, right? This is a fact. We take it as fact, right? For some sample. Let's say this is just iron or something. All densities are actually facts. Everything has an assigned density, but let's say this is iron. So let's say it's iron. Okay. How I write that as a conversion factor if I wanted to convert to something else, 0.210 grams per 1 milliliter. If I have per a unit, it is per 1. Just like miles per hour. If I'm going 70 miles per hour, I go the length of 70 miles in 1 hour. You're going to do a lot of density equations. Just because it is one of those equations that we make you memorize at first, and if you forget them, you're kind of in a little bit of water. Want to do more water problems? Okay. So we're converting density in this one. So convert 0.0045 kilograms per milliliter to pounds per quart. Pounds and quarts, or what kind of measurement? Very English or standard, right? If you are not from the US, I don't know. Maybe. You can't ask your professor about what they can put onto the test for you to tell you standard conversions. They might tell you just to memorize them, okay? Inches in a foot, feet in a yard, that kind of stuff. Quart in a quarts and pounds of water. But quarts in a cup, cups in a quart or whatever, quarts in a gallon. They may ask you to memorize those, but some of them might just put them on the test for you. A lot of them just assume that we learned that through life as Americans, but not everybody's American. Okay, this is one of my curves. If I go through the pain of doing what I did here and converting everything individually, it takes way too much time. Also, it's not as efficient. Okay, so if I'm converting both, or hell, even one, but it's a per, right? Like if this was still milliliters over here, I can still do that. But if it's a per, right, that's 2. So 0.0045, we start with what we have, right? That's kilograms. It's per 1 milliliter. Okay. Now we can go straight into how we convert things through that. Okay. You have to pick which one's first. Which one do you want to convert first? Which unit? It doesn't matter. Kilograms. Okay. Kilograms is up top. Has to go down below, right? Normal rules. What are we converting to? Pounds. Look at the front of my conversion packet. Is there a conversion that even comes close? I have a standard measure, yeah. The very bottom. We're going to pounds. Right. So yes, we can. Or I'm actually gonna make this longer for you guys. Okay. We're gonna do 1 pound equals 454 grams. Okay. So I can't convert straight from kilograms to pounds. That's what I'm telling you now. Okay. So we have to convert to our base unit first, grams, because I'm gonna use a conversion factor that has grams in it, so we need to go to grams. Okay. So which one's bigger? Okay. Do you want to do my method or Lions? It's not that good in Lions, correct? You want to do Lions? Okay. So our smaller one is gonna get our 1. So, okay. So 1 gram. Oh, sorry. Okay, that's so be true. Right? Or smaller one, so the one that you negative.
Oh.
Okay, so if I have 1,000 kilograms, does that equal 1 gram? Yeah, right? I would have to have a fraction of a kilogram equals a gram. 1/100, 1,000. Okay. I know that's right. Okay. So our smaller one is always gonna get in lines is okay, so we have kilograms gone. What's next? Grams, okay? So I did this also, I convert to pounds. So pounds goes on top. So, and my conversion is 1 pound to 454 grams. So my grams do cancel, and I have pounds left, right? That's what I want. Okay. So I don't need to do anything else with pounds. I've already got pounds. So now we need to do our other conversion. Milliliters to quarts. The milliliters on the bottom, milliliters has to go on top. We keep pounds where it is because we want pounds to stay. Okay. I have milliliters to quarts equation. Okay. Because I don't remember my quarts. So I have here, so quarts goes down here, right? So I have 946 milliliters is 1 quart. So that gets rid of our milliliters, right? Are we done? I mean, other than putting it to a calculator, are we done? You're good? Yeah, but are my units done?
Yeah.
Yes, my units are done. Multiply the top, multiply the bottom, divide the top by the bottom. Like this. Give me all your digits. Big number? No decimals there? Okay, what is it? No decimals? No, there should be. No decimals there. Anyway, all right, does everyone agree? Okay, what'd you get? 9.3765. Okay, did you put your signs of quotation in parentheses? Okay, did you? Yeah. Okay, so let me.
Did you want, should we like do it completely separately, like the multiplication right now? And then?
Yeah, you can do that.
Okay.
I think
That
usually
might-
that's easier.
that might be different.
So if I don't separate anything,
Um,
9.37, 665, 198. You can also, this, multiply by 5, multiply by 5, multiply by 5. That's what I do. If it's one, I skip it. Yeah, that makes a little bit.
So I'm just kind of confused on like how you put like, just change the from like mass to volume. They're like, is that for like this?
So we're not changing mass or volume. So my pound is here.
Yeah, like you go from mass and then.
So this is not being converted.
Yeah.
This was converted and then just stays there.
Okay.
And now we need to convert our volume.
So it's like.
So you could do it all in one.
I just-
Because-
you just have to like, not in my book, or what.
So this will be pounds per volt. So we still have. Think about it. Still, if my units are still being divided. Pounds per volt, like they are, but that's it. Yep, 2. So 9.4. Pounds per. Yeah, you can do it all in one breath. You just need to make sure what needs to be on top, needs to be on top, what needs to be on bottom is on bottom. By following this. So if I got rid of all these, can I get rid of the numbers? You- I don't need to look at numbers, right? Kilograms on top, so it needs to go on bottom. Grams, pounds, done. Okay, milliliters is on bottom. So milliliters goes on top, get crossed out, I'll get quarts. So because it really looks like this, where I have kilograms times grams times pounds times milliliters. And then down here I have milliliters times kilograms times grams times quarts, okay? And just like algebra, if it's on top and on bottom, you can cross them out.
When does pounds get multiplied by volume?
Those are being multiplied at our top. I know, that's freaky. But if we look at the units, and just how we're multiplying units, if it's on top and if it's on bottom, we can cross them out, right? Because it makes a 1.
Yeah.
Right, like it's a variable. We just look at it like a variable. Kilograms is on top and bottom. Grams is on top and bottom. Milliliters is on top and bottom. So we get pounds per quart. We can also do this with miles per hour, so like kilometers per second. We can do, that is actually what we're gonna get, if you run a marathon at this speed, convert it to. But if I still have what's on top, it's supposed to be on top, what's on bottom, it's supposed to be on bottom. This is, it's freaky, but a lot of time figuring it out and understanding it, is just doing the whole thing. Let's see where you mess up. A lot of time you're not really gonna do the measure to standard, at least in long form. Those are different. You can give me one more question, can you give me?
Sure, good question.
You guys know how like we do cubes, like area volume. Like, if I have 9.4 cubic or centimeters cubed, that's about, that's volume, right? Right, 'cause we do a cube. If I wanna go to millimeters cubed. Millimeters, cubed, centimeters cubed. Okay. I start with what I know. Millimeters cubed. Centimeters cubed, that's on bottom, right? Okay. And I'm just doing units for now. So meters cubed, right? Meters cubed, that's on bottom. And then millimeters cubed. You're first going to write what the actual conversion would be if there were no cubes. Okay, so meters is bigger, so I guess my 1, and then there's 100 centimeters and a meter. Okay, same thing over here, there's 1, and then there's 1,000, or 1 times 30. Okay, but because it's cubed, our unit is cubed, our number has to be cubed for the conversions. So everything gets cubed except the number I started with, because this is already a cube. Everything gets brought to the. Sometimes these are done in squares, same thing.
Sounds like right.
But the reason they're done like this is because this is a meter, right? This is 1 meter. 1 meter, 1 meter, 1 meter. Right. Right. If I wanted to do meter squared. Pretend that's a square in a rectangle, right? That's 1 meter. 1 times 1. Volume area. So we're doing the inside. An area is width times length. So obviously 1 to the 3rd is just a 1. So this is what it looks like. 4 times 1 meter. 100 to the 3rd is 1. Sorry, no. Million of 1 times 10. 6. 3. 5. 2. And if you don't want to do that on your calculator, you don't have access to a calculator, 100 is really 1 times 10 to the second, right? If I take that to the 3rd, I multiply, right? So 2 times 36. 1000 is 1 times 10 to the 3rd. If I take that to the 3rd, 1 times 10 to the 3rd. So 9.4 times 1, right? Divided by 1 times 10 to the 6. Times 1 times 10 to the 6. So you should get 9,400. Will be the two. Did I do right difference? That is common. That's by the way, it's not that point. Yeah, so I have 2 sig figs there, I have 2 sig figs in my start. So that's how we do the cube of the square root. There you go. Now, you don't know what joules are yet. Is this a complicated version? It's not. Yeah, so they don't both have the same base unit. So this is just like doing meters or grams or liters, kilo, milli, right? So we start with what we know. Kilojoules. What's next? What do we convert to? Yep. Which one are bigger? What you know about kilo? That's 1. I have 1,000.
But how is that gonna be on that thing? Should I do like?
Is kilo one thing?
1 kilo plus 1 to 10.
Get 1. Your smaller one gives the 1. Yeah. Okay, so our units change though.
Yes.
Yeah. So we still do it here. Down here. So our smaller one gets the 1. So I have 1 times 10 to the negative 3rd kilojoules. Yeah, because I have a fraction of my big unit. Kilojoules. Okay, now we need to get rid of joules. We need to go to milli. Which one is bigger? Okay, so millijoules gets the 1. We do the same. Where's the 0.3 divided by 0.00? 0.00. Yeah. It should be huge. Should be small. Because if I divide by a decimal, I'm gonna get bigger, right? If I divide by a fraction, I get bigger. If I multiply by a fraction, I get smaller, right? If I multiply something by 0.5, I'm taking half of it. Okay. If I divide by 0.5, I'm not taking half of it anymore. I flip fractions. Remember when I divide by them? Okay. So if I put that fraction, I have 2/1, so I multiply by 2. Divided by 1 times 10 to the negative 3rd. I got my answer, and then I divided by 1 times 10 to the negative 32. You're putting that -3 in there?
Yeah.
Oh, 'cause you don't need to put parentheses around the -3.
Like, when you- Sorry for that. Do something real personal and you divide it again.
Because if I divide by fractions, let's say I have 3/4, and I divide by 1/2, which is really 0.5, that turns into 3/4 times 6. Alright, so those right? Right,
You would tell us it is one dual equals one, but if you wrote out that's a fraction, if you wrote that out, one dual,
this, or this one?
that one, if you wrote that out, one dual equals one. No, it's like, fuck this thing. I'm just confused why it's -3.
Because the is bigger. So let's do this.
So, I know it's bigger, I would just think it would have a positive exponent for some reason, I don't know why.
So positive would be 1,000, 5,000 kilojoules, I can't possibly equal 1 joule. The joules are smaller. Right? So if I have a meter, right, and I want to get to kilometers, it's the same thing, kilometer is bigger, but I just take a fraction of that kilometer to get a meter.
Or if I wanted to write it the other way, then it would be one kilojoule equals 1 exponent.
The joules are smaller, so I can more of them. I can't have a fraction of my smaller units equal bigger. It helps also use your units when you get your total. I should have a crap ton of millijoules in a normal convention. Right, kilojoules are so much bigger than millijoules. Right? 1,000 both ways, right? 1,000 bigger, 1,000 smaller. Yeah, 2/7. 2/7, right? Yeah, it's